All right. Ayo, we are back again. Back at it again. All right. Come on in, take a seat, sit it on down. We are about to get started here. Let's start the show. All right. Thank you again for joining us for another session of Designer's Corner. I'm your host. My name is Josh. I'm a professional UX designer, and I am here to help you get a job. So, what do we have here? We have my socials: YouTube, Twitter, and Twitch. So right now I am on, you're probably catching this on YouTube, as that is the only streaming platform that I currently have set up. I'm still in the works of getting this thing all calibrated. I have to go ahead and get the multi-stream going. But for the time being, I have YouTube, I have a Twitter. You can find me at DesignersCorner. No E in designer, no second E in designers. So DESIGNRS, Designers Corner. Similar with Twitch regular, Designers Corner, DESIGNERS. So go ahead and find me on the socials. I won't be on Twitch for too much longer. We're probably going to move over to Kick instead. And so once we kind of make that transition, feel free to add me there, find me there. On any of these slides, the link is down below in the description of this video. Go ahead and you can access the presentation afterward. Once you do, you can go in, find the links in the slides to any of the socials. Also, we have a new check-in system on Twitter. So basically what you're going to do, go into the description, you'll see check-in and their link. Go to the latest post. That'll let you know that we're live here. Go ahead and like that post and retweet it to let me know that, you're participating here, that you're active, that you're present here. And that way we can give you credit for being part of this community and joining the presentation. So that way we'll know that you're here. We'll get you checked in, signed in. We'll know that you're taking a look at what we're doing here. So last week, why are we here? That was the question we were asking. And the answer, we're trying to get those jobs. Get that money. Yeah. That's what we are here to do. That's what we are here to do. And so if you're here, which if you're watching this, you're most likely dissatisfied with your current career and standing in life. You are acknowledging this about yourself, and you're taking active steps toward changing your life. So congratulations. You are here to learn a new skill set, most likely. If you're not already a practicing graphic designer trying to break into the UX design industry. I know that I certainly was a graphic designer prior, and it took a little bit, before I finally heard the term UX design. But when I did, I knew it. I knew that is exactly what I wanted to do. So now I'm here. And I've been in a professional designer in the industry for over a decade now. So I'm trying to just share my knowledge and expertise with you. And most likely you are here because you have an interest in design and problem solving. And that is a beautiful thing. Most likely you're here because you're not here right now. You want to be a UX designer. You want to get involved in this. But if you're not there right now, if that's not the point in life that you're at, but you want to be here, again, congratulations, pat yourself on the back. The hardest thing is admitting that you have a problem. Step number 2 is doing something about it. So if you're here, you're already on step 3. We're already past that. And if you're here in life, you might be currently stuck in one of these jobs here, working Walmart, Uber, DoorDash, if you're working grunt labor at any one of these places, it's time to stop. Just stop. Just stop. Go ahead and stop. We don't leave that to someone else. Leave that to no. That is not for you. That is not what you were meant to do. If you're here, you're a problem solver, you're a thinker, you're a philosopher, you will be an architect, an engineer, you will be an accomplished mind. If you are not working any of these places at corporate level, it's time to stop. It's time that you start applying yourself for real, that we start focusing on design, learning design, and trying to get that job. So last week we asked, what is UX design? What is it? You know, what is it? And we took a look at some definitions. All right, they had a bunch of fancy terms, fancy schmancy terms. You can go ahead and throw that all out. All right, decisions. That's all it comes down to. That's everything that we're working toward here. Making a decision. That's it. Making a decision. In the day-to-day grind of being a UX designer, you are problem solving. You are figuring out what the best solution is to a problem that most likely arises on the internet, in graphic design, in a computer language of some sort. You know, you're either working in Figma, you're working in Sketch, you might be working in Photoshop, whatever tool you're using, there is a problem. And the problem is, how do I grab attention? How do I make sure that the user, the customer, the client understands what I'm trying to communicate here? And it all comes down to making a decision. So, for an overview of the course, again, we're still in that semi-stage of the introduction. This is technically week 1, session 2. So we're still in that introduction. We're still just kind of glancing over some things, covering some concepts, making sure that we're on the same base. You know, we understand each other here. We understand some of the concepts that we're going to use a little bit later on before we even get into fully, you know, design thinking, principles of design, all that kind of stuff. Before we start using the tools, actually, we're just trying to figure out a few things that we need to understand before we fully get rolling here. So I need to update the table of contents quickly. But prior to, you know, we'll just move right along and get right into simple concepts. So first things first, what is a raster? What is a raster? And if you haven't heard this term before, in short, it's going to be pixels. It's going to be an image. Now, the definition from Adobe, pretty good source to get it from, also known as a bitmap, raster files work best when you need to store and display high-quality photographs. Okay? We're all familiar with high-quality photographs. We've all, you know, have the latest iPhone, you know, taken high-quality images. You take an image that's only this big on your phone, and you can just zoom in, blow it up 1,000 times, see all the micro details all the way in the background. Those are high-quality photographs. Why? Because they have a large number of pixels included in every file. In every file, you might be taking, you know, is megabytes. If not, you know, you're probably getting into gigabytes if you're taking video and stuff like that. Why? Because there's so much data stored in each of those photographs. Most photos come in the raster file format, whether they're print or digital. So most of the time when you're working in any type of image software, image manipulation software such as Photoshop, you're going to be working with bitmaps or raster files. That comes down to the pixel. No, not the Google Pixel. This is a pixel, a single pixel on your screen. Now, if you have a broken monitor, God help you. But if you have a monitor of any sort, if you have a desktop monitor, if you have a phone, if you have a tablet, a TV, any type of a digital display on the camera that you use, every single monitor or display uses pixels, thousands of pixels per square inch. I think normally the idea is DPI, density per inch. I think it is, but point being, it uses many pixels, each one of them just being a little square. Each little square, this pixel on our screen right here, this blown up version of a pixel, contains such little information. Right here, this is the color white. In RGB, it's 255, 255, 255. That makes white. And right now, this pixel can only hold that information. It can't hold anything else. It only holds the color white. Now, once we start to form a larger collection of pixels, this is where things start to get interesting. Interesting indeed. So, once we start to form pixels, in a simple terminology, you may start to get pixelation, or what's known as artifacting or artifacts, when it comes to this type of stuff. And what are artifacts? Artifacts are the pixelated quality of what should otherwise be a high quality image. And it usually happens when you distort an image, probably by scaling it up. Many of the pictures that we take today, high quality photographs, they can scale, you can zoom in a lot. But if you zoom in too much, then you're gonna start to notice those pixels. You're gonna start to see, the blurriness. It starts to get a little blurry. You were like, okay, this was good before. I don't know what happened. That's artifacting. That's the pixelation. You're starting to blur that boundary where, every single minute pixel, each individual pixel, is starting to come to the foreground, and that starts to get into a little bit of some shaky waters there. Not the best situation, but we're going to talk about how we can kind of remedy that. How a lot of the solutions that we use today take care of that issue, and they don't allow for that anymore. Not anymore. Not That's not a thing anymore. We're talking about it because this is very much in use. But we'll see the other side of this as well. So once we begin to kind of zoom out and produce enough pixels, then that's when we begin to form an image. Yes, we're forming an image. So the image on the left is taken from the image on the right. The image on the left is zoomed in way too much. You can see it blurry, cloudy. You're starting to get all those little artifacts going on. But if we zoom out so that we can actually begin to see the picture, our brain will automatically construct what we're seeing here. And it will allow us to put each one of those pixels, every single pixel that contains just the color white in it, when placed next to a pink, a red, a yellow, an orange, a green, it will begin to form a full image. And that is one, a good thing, but two, we begin to understand the psychology of the human mind. Because when we have, this is the reason why we're striving for 4K, 8K television. It makes a clearer picture. It allows our brain to digest this information in a different way. And if you just had one flat color, you would just see a wall of just that color. But once we begin to introduce some dark tones, some light tones, and it has that play and contrast, that's when we start to make out, and I'm assuming that you can't make out every single individual blade of grass, or rather the stem, in this picture of the various flowers, but your mind knows that it's there because it knows what a flower is, and it sees the greens against the darker greens, probably the dark shades, as the shadows allow the colors to pop. And even though the flowers in the background are this shot because of the focus of the camera are blurry, our mind still understands that this field of flowers extends backwards. And that will get into some of the design principles that we'll kind of understand and examine later. But for right now, all you need to know is that this is how it's done. We're taking some pixels, putting a bunch of them together to form an image. Now, sometimes, you have what's known as pixel art. And this comes from, the early days of mainly video games. And a lot of times it's due to the constraints of the hardware. And so, Mario here, very recognizable character, no one's gonna not understand who this is. But he was made based off, I believe, this might have been 16-bit at this point, but things, if you can think of Pong, if you can think of Space Invaders, more 8-bit systems. And so this style, this pixelated style, is still in use today. Why? Because it's easy, it's simpler, it's fun, and most important, it's classic. So it's fun to make because you have to design it. The designers who made Mario back in the day, they were working with the constraints of the consoles and the devices that they had to work with. But they didn't throw their hands up in frustration. No, they made decisions. Look at every single pixel here. Look at the way that his overalls on the left side of his left side, fall short of coming up to the neck. Now when you have the animated version, the pixels will change and their placement and stuff like that. But look at the way that our brain can make out the detail. How the ear sticks out from the hair. How the hat on his head looks like a hat. The eye, the mustache, the nose, the overalls. This is by no means a high quality image. But our mind understands because of the decisions that the original designers of Super Mario Brothers, made when creating this franchise. And Donkey Kong came before Super Mario. That, regardless, they made a decision to place each pixel in a specific location, and that's how we got here. And so we move on to vectors. So we already examined the pixelated side of things. Pixels are kind of set in stone. They're pretty simple. They can look great. They make a great image, but they're limited. They only hold basically one property of information to every single pixel. However, when we look at vectors, we're talking about points. We're not talking about pixels. At no point in vectors are we talking about pixels. Now, you may have heard of a vector. Even, is it Asteroids? I believe it's Asteroids. Was a game back in the day that used vectors, and it was pretty revolutionary for the time. And vectors are made with points. And these points, now this may look like a pixel, but it is a point, and it is very different. It functions very differently from a pixel. A point holds, I don't know exactly how much information, but a lot more information because of the way that the computer interprets a point. So, before we can fully dive into that, we need to understand a line. So a line, by definition, is a straight, one-dimensional figure that does not have thickness and extends indefinitely in both directions. So even though, this visual interpretation is showing, a line that's only this big, but you can imagine that it just keeps going and going and going just right off the screen. It goes in both directions right off the screen. And this line is not very helpful to our cause. So now that we know that a line is indefinite, goes on forever, what does that do for us? How is that going to help us in this understanding? You know, we don't want our designs to go on forever. We don't want our lines to go on forever. So what are we going to do? We need a marriage between the point and the line. That marriage is called a ray. And a ray is a line with a definitive starting point, that being the point itself, the point that we examined a moment ago, and it extends all the way into forever. And so when you have this ray, you may have heard of the concept of ray casting before. This is something that a lot of websites or game developers, have used in the past to kind of determine when crosshairs are placed over a certain object. So if you're trying to do a point and click of any sort, what the developers do in a lot of cases, they will cast a ray from the point of where your mouse, your cursor, your crosshairs are, and it will shoot forward starting from that starting point and go forward into eternity. And it'll do this for a second or two. It won't go on for the line extends all the way into forever, but the time that the line is active is only for a short duration. But in that time, as it sends the ray forward, if anything is in the path of that ray, bam! Look at that bacon sizzle. That's when you get your headshots. That's when you click on objects. That's when you do all this stuff. So that is the usefulness of a point and a line. But what we now want to focus on is 2 points and a line. If 1 point can give us our starting point, then a second point can give us our ending point. And this is where we start to get into the magic of understanding the geometry of this stuff. Now, I'm sure, a lot of difficult math goes into creating a line on a computer, rendering it, and all that kind of stuff. It's probably, simple math in terms of as complicated as math can get. But the point is, I don't know it. You don't need to know it either, because the computer will render this stuff out for us. So when we look at our line, we're understanding that a line segment here extends from one point to another point. And once we understand that, we can begin to harness that. We can start to understand that we can curve our lines. So we'll not only have a line, but we'll have a curved line as well. And so a curved line, like I was saying before, that can be achieved by vectors through handles. And the handles you can see on the left side there, those little handlebars sticking out from where the vector point is, those can help us to manipulate our lines in this space. And now once we begin to understand that aspect of it, we can move on to even greater understanding of, the properties of the lines that we're putting on our page, our canvas, our frame, our artboard, whatever you want to call it. So if you want to learn a little bit more about lines, this is a nice little article that I found on Splash Learn. And it's what is a line in math. This goes over lines, obliques, curved lines, all different types of stuff. There's some math problems in there. Sometimes it's nice to just brush up on this stuff, just kind of get reacquainted in case you're wondering. But that is kind of where this comes from. Not the concept of a line doesn't come from this website, but the website goes over what a line is in case you're wondering. So what do we do now, and where does that get us? So we've covered pixels, Those are great. They're what's in everyone's camera. They take great photos, not so much in the dark, but technology is getting a little bit better. And we've covered vectors. Vectors are an oddity. They're not what you're used to. They seem useful. That was cool, cool story, bro. Cool story about the lines and the stuff, all that. I liked your drawings and all that. What was that? What does that do for us though? What is that? What does that do? Where does that get us? That's when we get into shapes. Shapes are going to be the building blocks for the designs that we're ultimately going to make. And so when we get into shapes, a lot of these shapes, a lot of what UX design is based in vector. And so those vectors, when you have 4 lines, you can create a rectangle. If you have 4 lines and some curvature, you can get a rounded rectangle. If you have some curved lines, you can get a circle. If you have 3 lines, you can make a triangle. These are the simple building blocks, but the concepts are going to be important because we need to understand that, we start with our line and we begin to build off of that. And by building into shapes, everyone's familiar with a square, everyone's familiar with a circle, everyone's familiar with a rectangle. We don't need to get nerdy about this. We're not going to have to, do anything outrageous with these shapes, but we do need to understand that we need to harness these shapes, and these shapes are probably going to be constructed from vector lines. And when we understand these simple shapes, we'll start to understand a little bit more. So we'll start to understand some simple transformations, Rotate a square and you get a diamond. All right, that's the same shape. If you've never seen a little test like this or whatever, same shape. You just rotate it 90 degrees and you get your square becomes a diamond. And it may not seem like much, but that diamond communicates a completely different idea than the square does. The diamond is more aggressive. It's more demanding. Look at the lines, the sloped lines of it. The square is more passive. It's rounded. Like, there's a reason that we call something that's lame, that's boring, square. We want, with that diamond, we're communicating something. We're communicating something different than what we were with the square. We get into some shape manipulation. As I was saying before, these shapes are probably made up of vector lines. And so those blue circles on that diamond shape, you can see that if we remove one of those points, and the computer will have to recalculate it. The computer wants to move from one blue point to the next blue point, and it probably does it in clockwise and sometimes counterclockwise direction. But if we get rid of that last point, that bottom point, it will take a look at point number 1, point number 2, and then it will look at point number 3. Let me just, point number 3 here. And then it will go all the way back to point number 1. And it will understand that those 3 points create a triangle. And through this shape manipulation, through understanding how to manipulate our vectors, we can use that to create new constructions. So remove that point from the diamond, it becomes a triangle. Now, when we get into some other shapes, you can also round your shapes. That rectangle becomes a rounded rectangle. That diamond can become a circle if you round out all the corners. And if you round it enough, see, each line is made, every line of the diamond is made of a straight line. But if you can curve each line of that diamond, of that square, it can become a circle. And so that's done through vectors, through the calculations that the computer's doing. But even though that's, fascinating, again, cool story, bro, it's not about what the computer's calculating. It's about what we as designers are communicating. See, when you take a hard edge shape like that and give it a roundness, you're forming a gentler and less assuming shape just by cutting corners. I'm trying to think if there's any pizzas. Now there are a lot of pizzas that advertise that they don't cut corners. So this is kind of an inverse example. But when you have a round pizza, everyone knows that a pizza, is normally shaped round, and then you cut it into triangles. And then some of these places advertise that they don't cut the corners off of their pizza. And in the decision making, in the marketing that they're doing, that's brilliant. So they've done the inverse from what we're showing here, the arrows pointing from the diamond to the circle, but they did the opposite. They went from the circle backward to the diamond. And they advertise that as, you're getting more pizza. We're doing you a service by giving you a better deal. We're not cutting the corners off. We're not rounding those straight edges, those straight lines, and giving you a circle. We're giving you a square. And a lot of people probably remember either that campaign. I don't remember which pizzeria was doing it, but it's that kind of decision making, that kind of marketing that can stick with people. And then we start to get into even more complex shapes. So the arrow that you may have noticed and probably didn't even notice throughout these couple of slides, that arrow is made up of simple shapes. It's just a bunch of rectangles sitting on top of one another. And so here I've deconstructed just to show you. And once we start to learn about, this is why, understanding these shapes was important. Understanding how the roundness, the smoothness, the hard edge, the soft edge, what it communicates to us and how we're using it, we can use it to create more complex shapes such as this. And any complex shape such as this can be broken down into the simple shapes that form it. And this is where things start to get interesting. Now, if you had, a button on your website or whatever else, and it was just a square, a circle, a diamond, no one's going to blame you. It's fine. Perfectly fine. Works perfect. Some shapes probably better than others in terms of communicating. You want to think about the surface area, the amount of space that the user has to click. You don't want to give them just a little tiny area just to click there. You want to make sure that you give them enough space to click on it, and you want to probably make it inviting. Softer edges, probably more inviting than harder edges. But once we start to understand these complex shapes as well, we can begin to form and manipulate. We can begin to use our vectors to create even more complex and more intricate, some would call them organic shapes, based off of the vectors, the lines, the curves, and all that kind of stuff. So, now that I've probably got you thoroughly sweating, it's time to shift gears once more. We're going to look at the pillars of creation. So these happen to be the 4 pillars of creation as well. And these are the methods that go into almost every single software that you're going to use. Everything that we took a look at last week, anything you do in Figma, anything you do in Photoshop, anything you do in After Effects or Premiere or any of the video editors, these are going to be those types of methods. And I'm not going to call them functions just yet, but these are going to be those methods. Now this one is an interesting one. Basically, I've concocted this through my years of experience. This is what I kind of understand to be what's most necessary in these programs. So thank you for joining us, everyone. Glad to see you here. And these are the pillars that are going to keep you from getting distracted with all the fancy fans that these programs like Photoshop, which we'll probably take a look at next week, these are the things that go into Photoshop, uh, but but they can be used. They're not the liquify tool. They're not the Gaussian blur. They're not the smudge tool. They're not fancy things like that, but they are the basis of how those things work, and more so what we're manipulating to make those things effective. So we're looking at selection, vector, pixel, and masking. So what is selection? Selection is a method used to do exactly what the name suggests. It selects. So oftentimes you're going to either select a whole object or you're going to select a part of an object. And so selecting a part of an object or a whole object is often used in conjunction with standard manipulation methods such as transform, rotation, copy, paste, delete, scale. So these different ones. Transform, it's not a Transformers Autobot. It's not anything complex. It literally just means translating and or just clicking on an object and moving it to the left, moving it to the right, moving it up, wherever you want to move it. You can transform. You can move an object to a different place. Rotation, just like we looked at with the square, can turn to a diamond. You sometimes just want to rotate an object just to get a different effect, a different feel from it. Copy, paste, delete. Now these ones aren't shape manipulation, but when you use a selection, when you use in Photoshop, we'll look at the marching ants, we'll look at some other stuff. That there are different like editor properties. There are different properties that you can manipulate of the object that you're selecting. And so some of those you want to select a portion, you want to select a couple of objects in your design and copy those, and you want to paste them somewhere else, or you want to just delete something. It comes down to selecting. As well, we also have scale, which can also be squash and stretch depending on if you're scaling uniform or not. Make sure you're always holding that shift key. Except I think in like Google Slides or something, a couple of them are backwards, and the shift key actually messes you up and makes it not uniform. But actually, I think that's the new versions of Adobe. Anyway, point being, make sure you're holding that shift key when you're scaling. You always want to scale uniform. And there's a couple of other methods and other things you can do to manipulate, but these are the main ones that you want to take a look at. Everything like such as vectors. We've already taken a look at what vectors are, but most of our design software that we work in with UX design, so probably Figma or Sketch, the main two, those are going to be vector software. And vector shapes, are drawn using the computer using points. These can be shapes that come standard with the design program, or that you draw yourself. You don't have to draw all these shapes yourself. Most applications have a circle, a square, a triangle, even some star shapes. They do a good job with allowing you to manipulate a basic form of a shape, and from that, they'll give you a basis for what you can do. But understanding that when they offer you a square, you can form a rectangle from that as well. So understanding how these things work, again, that's where the vectors come in. That's where the understanding of shape comes in. And then by the end of it, we'll also look at how to draw these yourself. The pen tool can be a beast, but at the same time, it's also a beast. So, a lot of graphic designers and illustrators, they use the pen tool, they use it well, and they use it for organic shapes. So not every shape, if you're looking for a crescent moon type of shape, some programs might offer that, but you might either need to get a little bit fancy by manipulating through some masking, or you can draw your own crescent moon shape, just as an example. So vectors are versatile, and vectors scale. Vectors can scale, and that's one of the big things that vectors do. And so what that means is that vectors are magical in comparison to raster images, because vector shapes, they're based on calculations. As I've been saying before, a vector shape is drawn using points. It uses 1, 2, 3, 4, however many points. And from those points and the handles, the computer calculates what shape it needs to render. So if you just put down poop, 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 4 points and close it off to connect it, it will draw a square for you. And through that, you will have a square of a certain size. And so with that square of a certain size, you might find later on that you want a larger square, or a rectangle, or anything in between. And through that, you can manipulate that vector shape. Now, normally when you have a raster image, the image is what the image is. The pixels, they don't stretch the image. If you want to change your 3x4 image into a 16:9 image, just doesn't work. It won't stretch. It doesn't work that way. A 1x1, can't become a 16:9. What I'm saying is the raster is set in stone. The vector can be manipulated, it can be squashed, it can be stretched, it can be scaled up to any size, and it will look great. A vector maintains the quality of the shape that it renders because there's no pixels involved. It never uses pixels. It uses a calculation that looks from one point to the other point to say, all right, I need to bend at this angle, I need to move this distance to get to the next point, and it fills in whatever shape you have to complete the shape that you're trying to go for. Now we'll come back to the pixels as well. So we had selection, vector, coming back to pixels. Pixels are still useful, all right, as we've been talking about this entire time. Sometimes you just need an image just to get the trick done. So pixels are still useful. Pixels are very much still in play, even though they're not the main source of what we use as UX designers. And then you have masking. And masking is the true magic manipulation and creation. Masking is a method of blocking, excluding, and occluding part of a shape or a whole shape. And sometimes you can even use other shapes. You can layer one shape on top of another shape and tell a shape to sit within the confines of another shape. So we've looked at selection. You select an object. We looked at vectors. Those are magical images that use calculation rather than pixels. We've looked at raster images, which use pixels, and they're pretty set in stone, but they can create high quality images. And now we're looking at masking. Masking is the magic trick of any of these programs. So whether you're using Photoshop, whether you're using a vector base like Figma, masking can do a lot of fancy solutions for you. It's the basic concept of now you see it, now you don't. And sometimes they're referred to as Booleans, but that is going to be within a vector program. So masking is a form of soft deleting. So to go into Photoshop when we get there, there's going to be destructive and non-destructive methods of manipulating photos. Something destructive, if you can think of a Word document, going in, selecting everything and pressing delete, and then even saving. That'd be saving, closing the program. You're not getting that back. No, that's destructive. However, if you can imagine if you can imagine a person and you tell them to go stand behind that curtain over there, go stand behind that wall, or even just playing peekaboo with a baby. Now, even though we cover up, all right, we cover up an object, it's not gone. It's still there. And as humans, we understand that it's still there, it still exists. We have object permanence. We understand it. But the magic of it is that it can appear as if it's gone, as if it's been transformed, as if it's not the same object as it was before. And that's where masking comes in. Masking does a great job in Photoshop for the pixels. And when we look at vector objects, we'll sometimes look at booleans. And booleans are one step above methods. So if masking is the method, then booleans, let's say, are a function. And even though, some people who might be some devs might, be a little bit confused by that, because a function is kind of the lower of the two versus the method. But without getting too complicated and too much into the weeds, just to call it, a Boolean is a special method that is used on vector shapes and can perform various actions such as splitting, joining, dividing, removing, making compound and composite shapes, and a few other things that it can do. But basically, it's the exact same thing as masking, but more so for vectors, and it's just a different name for it. It's just a different property in terms of what we're doing to mask, but it's the same exact thing. And we'll get there once we when we take a look at probably Illustrator, just to show you the pen tool and to illustrate the point of all this. So we're coming toward the end of class, so thank you very much, everyone who's joined. Don't forget to go to the Twitter and check in just to make sure that you get credit for this class. The link is in the description to go check in. But your assignment this week, just to keep it simple, we're going to make pixel art. And so I have a bunch of links here to different pixel art creators. If you just go to Google and type in pixel art maker or anything like that, these types of links will show up, and they're browser based, they're free, and you can go in and you can just kind of play around with pixels. And what I want you to do is go in, use any of these free programs, and just create an image, draw a scene, use the pixels, use the limitation to your advantage, and go ahead and create an image, and then post it and at me, tag me on Twitter or whatever you want to do to kind of get it back to me. Again, I'm only on YouTube, Twitter, Twitch right now, so a bunch of streaming platforms, but not too many in terms of various ways to get it out to me. Hopefully I'll try to get on Instagram or something else. That will pend. But for this week's assignment, make some pixel art. Go to one of the links below. You'll be able to find the presentation in the description of the video. Check it out. Try your hand at some pixel art. Maybe you find that you have a knack for it. Maybe it's something that interests you. A lot of games and game designers still use a lot of pixel art, again, because it's a classic style. It harkens back to a classic constraint of the times, and people still enjoy it. It, like I said before, it's a decision, and that's what we're going for. When we think about creating art, you don't have to be Van Gogh, you don't have to be Picasso here, you don't have to create the greatest thing ever. I just want you to create a drawing. Anything from a tree, you can make a rock, you can draw a river, you can draw a mountain and some grass and the sun smiling in the sky. Doesn't have to be anything fancy, but we just want to get a feeling for the pixel, because the pixel is still very important to the creative process. And so that's this week's art assignment. So go ahead, go make some art. Last week, we might have found some of the links. So the appendix as well will have a bunch of the links to the previous programs that I brought up. And go download those if you like. Go give them a try. This week, we're making pixel art. So make yours, tag me, and at me on Twitter, and let me check out what you have and all that kind of stuff. How good you are, how bad you are. It doesn't matter. We're all in this to learn. And again, the fact that you're here. Let me reiterate this. The fact that you're here right now is enough to make you a UX designer. You do not need to be an artist. You do not need to have graphical design skills. You do not need to be able to draw a straight line. You don't even need to be able to draw a straight line. The fact that you are considerate enough to look at the position you're in life right now and make this decision, make this choice to join us here, to try to better your life, to try to make a change, to try to learn a new skill. That is exactly what we're looking for from UX designers. We're looking for problem solvers, we're looking for innovators, we're looking for engineers, we're looking for architects, and we'll get into what those terms mean exactly. Don't think of like a house architect. You don't need to be that good. You don't need to be any level proficient. We're looking for people who are at least willing to look at this stuff and think about how it could be different. How that square could be a rhombus. How that rectangle can be a rounded rectangle. And we're looking for people who think about what that means. So again, pixel art is this week's assignment, and go in and place those pixels with purpose. Whenever you place the pixel, whenever you draw it, you're going for purpose. So one of my favorite ones is the Pascal app there. So go ahead and try them out. I'm not showing any favoritism here. Low Spec was also a good one that I saw. I kind of ranked these in order from which ones I liked and preferred the most, but give them all a try if you want. They're all good. They're just the first couple that popped up. So even if you want to use something else, just go ahead and take a look. And I hope to see you back here next time. So thank you very much for joining us. And we're working towards something great here. So thank you again. Give yourself a pat on the back. You earned it just for being here. So we're gonna see you next time. Thank you so much, and we'll see you later. All right, take care.